Hi, everyone, and welcome to Data Engineers Lunch number 31. Unfortunately, our original slotted speaker and topic, the speaker is out sick today, so we kind of had to pivot. Stefan is going to step in, and he's going to be going over migrating from PostgreSQL to Cassandra, and some of the considerations to think about when you are making that switch from a traditional relational database to a non-relational database. The organizers for this event are Rahul Singh, Arpan Patel, and myself. And we are always looking for sponsors and speakers. So if you guys are have any topics that you would like to discuss on that you're the expert in, certainly reach out to one of us, or if you know of any organizations that would want to sponsor webinars, or when we get back to in-person meetups, if you know any companies that would want to sponsor, I don't know, bringing food or drinks or something. I know we've hosted these in the past at George Washington University. So definitely reach out to one of us. Our emails are listed there. Data Community DC is part of a larger community, or I should say Anant and this meetup are part of a larger community, Data Community DC. And it is an inclusive environment. So any culture, race, religion, any sort of thing, everyone's accepted here. And we expect, respect to be given to anyone regardless. Some of the other organizations associated with Data Community DC are listed here. And you can learn more at datacommunitydc.org. And you can see they have more events. They have their own blog. So definitely check them out. Looks like also a Twitter handle listed there. What we cover here, we cover anything and everything related to data. Largely, we deal with big data in general, but you can see here like data cleansing, ETL, sources, pipelines, all sorts of different topics. So again, to circle back to if anyone wants to present or speak here, Data Engineers Lunch can cover a wide range of topics. So definitely reach out to us. At this point in time, we like anyone new to the webinar, if they're feeling comfortable, to share their camera and audio and introduce themselves and what they do with data. So if anyone's new and would like to introduce themselves, this is meant to be somewhat of a networking event. So feel free to unmute yourself and say hi and what you do with data.
People are shy today.
Hey, hi, this is Chandra here.
Hey.
Are you guys able to hear me?
Yeah, hi, Chandra.
Okay, hi. Yeah, I'm new here, so I just joined this workshop session looking for registered with Eventbrite. Yeah, I'm working as a ETL lead developer, working in Informatica toolset, but we are using Python, Spark, and other things as well. So I'm working in one of my insurance clients. So we kind of do data analytics work in terms of pulling in data from multiple sources or different vendors, and apply transformational rules, cleanse data, and kind of prepare data for data analytics. And so we have tools like Spotfire and Tableau, where they do the dashboards and reporting work.
Awesome. Thanks for sharing, Chandra. Anyone else new and would like to share and introduce themselves?
Seems the session as well may be interesting because we use PostgreSQL, but I don't have any overview on Cassandra. So yeah, good to learn. Yeah, looking for the session.
All right. Sounds like the pivot in topics will be beneficial for you. Anyone else want to share? All right. We'll move on then. Okay, so some group rules. If you have any questions, feel free to ask it. We just ask that you be polite and courteous to others. And again, this is a discussion, so feel free to share what you know. sometimes the speakers will have their own rules in regards to asking questions. Stefan can go over that when he takes over. Some people prefer just asking questions in the chat. Some people are fine with unmuting and just asking a question. Here at Anant, we deal with big data ourselves, specifically Cassandra, Spark, and Kafka are kind of our main wheelhouse. We do host these discussions over a large range of topics, but those are kind of our area of expertise. DataStax is also a supporter and partner with us. Definitely check them out. They have a lot of really good talks on YouTube. They host regular webinars as well. George Washington University, as I mentioned before, has hosted these in-person discussions before. Hopefully we'll be able to get back to that soon. And again, with your sponsors, we could potentially provide food and drinks and that sort of thing, and make it more of it's always a little easier to network in person. So hopefully we can get back to that. And some of our other program sponsors are listed here as well. You could also be featured here. And some of the organizational sponsors to Data Community DC. You can see Capital One, Data Society, some of these other organizations. If anyone has any jobs, meetups, hackathons, anything they'd want to share, this is your opportunity to do that. We'll give you guys a platform. So if anyone has any upcoming events, feel free to unmute and share what you have coming up.
Hey folks, this is Will Angel here. Two announcements that I want to make. One is, and I'll put links to these in the chats, but the first announcement is Data Week DC 2021 is October 6th through 10th. It's going to be a free community organized conference. So I'll put a link to that in the chat in just a second. The other announcement is that Data Community DC has a Slack channel that everyone, or Slack workspace that everyone is welcome to join. So I'll post a link to that in the chat as well. Thank you.
Awesome, thank you, Will. And yeah, we can get that Slack channel listed on our intro slides as well to make it a little more readily available moving forward. Anyone else have anything they want to announce before we move on? Okay. One announcement we have here tonight, we are hiring full or part-time positions. Remote work, 100% remote work is available. Data platform operators, engineers, or architects, as well as any project managers. So if you or someone you know is interested in working with Anant, please send them to the link that listed there, careers.anant.us, because we are looking to grow. So yeah, let's get in contact and or send your contacts to us. That'd be great. Some upcoming events we have listed here. What we were going to speak about today was using Spark, Cassandra, and Elasticsearch for data processing. That'll be coming at a future date now, undetermined. That's why the X is there. Data engineers lunch I'll be covering next week is converting JSON to CSV. Since we all know CSV is kind of a common ingestion data format. And the sister lunch to this, Cassandra lunch, isn't listed here, but that occurs at the same time on Wednesdays every week. So also join us there, as well as as mentioned before, Data Community DC events. Data Wranglers also has some weekly stuff. You can find out more at anant.us/events as well. We have all of our upcoming events listed there. And that is all I have for the intro slides. So at this point, I will pass it off to Stefan, if you want to take over.
Hi, everybody. Just 1 second. All right, can you see my screen?
Yeah.
All right, perfect. Hi, everybody. My name is Stefan Mikulski. I'm a software engineer here at Anant. Fortunately, Nikita couldn't make it today, so I'll cover for him. We did cover this in Cassandra launch, but I think it's still an interesting topic. So, I'll still go through it. SQL to NoSQL. Mainly, I'm going to talk about migrating PostgreSQL to Cassandra. And by that, I don't want to say that one database is better. It's just, they're both useful for some cases. And, before you start actually building your application around your database, you need to know exactly which one to use, do some more research. But in case you're already started with PostgreSQL and you want to know about Cassandra and how to get started, I'll be covering some of the basic topics about working with Cassandra and the data modeling behind it. So, you can just get started, right? So first, let's talk about relational databases. PostgreSQL, I think we're all familiar with it. It has the ACID properties. We query the data using joins. It has a consistent global secondary indexes, scales vertically, and it's great for medium data. Yeah, all around great database for starting. I started with PostgreSQL. It's a little bit different than Cassandra, but it's more conventional and it's easier to start with, right? The problem with relational databases that eventually you'll run into is scalability, right? The way you scale this database is really not that, it's really expensive to scale a PostgreSQL rather than a Cassandra database. So whenever you try to scale, you might need to buy more expensive hardware, or you will try sharding. And whenever you do that, you basically split up your database in multiple databases. So whenever you do that, the ACID properties kind of like go away there. They don't apply anymore. You can do all those all those complex joins you always wanted to do. The schema changes, whenever you apply some schema change to one database, it's gonna have to be, you have to manually apply it to every other database. And then adding shards requires manually moving data, which requires a big team of engineers, a lot of coordination, and it just doesn't, it's just not so cheap. What I'm trying to say is, another thing is downtime, not just planned downtime, but also unplanned downtime. We always know that downtime is going to happen, but whenever you know you're gonna plan for downtime, you kind of like lose a lot of time with that. And in today's world, we should not allow ourselves to have some downtime, right? Well, so how do we solve all this problem? This is where Cassandra comes in. It's no relational database. It's highly available and it scales linearly. So that means that we don't have to buy more expensive hardware. We can just buy more commodity hardware, and we can just like use that to scale, which is a lot more cheaper. It's easy to manage operationally, which means like two engineers that can manage a 2-node cluster can manage a 20-node cluster, 100-node cluster. It's really made so that it's easy to manage, right? There's no master slave replica sets, and the interesting, not the interesting, but the part about Cassandra that really takes it apart from Postgre is the partition key. It's a lot more different than the partition key in the relational database. So first, let's talk about the ring, how data is stored. This is kind of visual representation. The way we talk is like we have the client and we have the coordinator node. Those talk to each other. Like I said, there's no master slave node, but any one of these nodes can be a coordinator node, depends on which the client talks to. And then the coordinator node writes the data based on where it's stored, based on an algorithm, right? There's a few things we need to know here. The replication factor and the consistency level are really important here, and those are set at the key space level. So the replication factor is how many replicas of the data we're going to have on the ring. And if we say it's 3, we're gonna have the client talk to the coordinator node, and it's gonna write it here, B and C. So we're gonna have 3 copies of the data. But the consistency level is how much of that data are we gonna make sure we read before we write. So we need to know exactly if it's written. So if we say consistency level 1, 2, I mean, so it's gonna write into one of the nodes, and before it sends back information that it's written, it's gonna need to reply from the other node, and then it's gonna send back to the client that the data is written. So we have consistency level of quorum in this case, right? So quorum is 51%, that's like 2 out of 3, and 1 is just 1. Even though we need information, for example, here that the data is written, the data is still going to be written here, but it's not going to check if it's written. So that's the difference between consistency level and replication factor. And also, the great thing about Cassandra is it's multi-DC, multi-data centers, so we can have multiple data centers in like West Coast, East Coast, and they work. It's really manageable, especially with the enterprise data stacks version. They have really good tools for that. Now let's talk about data modeling. These are some of the cases here, some of the high notes about data modeling between relational databases and Cassandra. As we can see, some things are different, kind of like in the order here that we think about when we think about data modeling. So if you use the PostgreSQL, if you try to migrate to Cassandra or trying to learn it, there's a few things that you have to forget and kind of like go from beginning because it's a little bit different. Like for example, in the Cassandra, we first think about the application side of things and the queries, and then we create our model data. Well, where in the relational database, we create the data model, and then after that, we think about the queries and the joins, how we're going to do, how do we scale, and how do we create our data model, right? Primary key is for uniqueness. We just set up ID in every table, so we have uniqueness. Well, primary keys in Cassandra are much more, and we'll talk about them. And that's basically the why we think about the queries first and all of that. Yeah, and joins and indexes, we have denormalization in Cassandra. We can't do joins, so we have to normalize the data and create separate tables for all our queries. So let's start. We have conceptual data model identify. This is kind of like the workflow in creating the data model, right? So we start with the conceptual data model and application workflow, and then we map the conceptual to logical data, physical data model, and then optimizing and tuning. This is kind of the same thing, but it's a little bit different. We'll get into it more. So the conceptual data model is identify entities and relationships. We kind of like take a step back and think about the entities and the relationship between them. The workflow and access pattern, this is where we identify the queries. And then in logical and physical data models, we just map the conceptual to logical and then specify the schema in SQL, so like the data types. That's basically the logical and physical data model. Is difference is when we transfer to physical, we do the data types in SQL. Okay, so conceptual data model, right? We kind of have the relationships here between the entities and the attributes, right? We need this. This is a great first step because in this step, more people can join in. It's just not for software engineers, even the project manager, even like non-technical people can join in and kind of look at the big picture and see how where our data is going, how it relates to each other, the constraints, the entity types, relationship types, all of that. There's a difference between so this is kind of like the difference between the entity types, right? We have one-to-one, we have one-to-many, and we have many-to-many. This is really important when creating your data model because we don't want weak entity types. And kind of like we need to put a little bit more planning in the first step so it's easier later on for our data model. After that, we have the application workflow. This is where we identify the queries. So this is a little bit more different now if you're used to PostgreSQL, because there you don't think about the queries after you create the tables and after you start working with your database. Here, one of the first steps is we need to identify which queries we're going to use in the database. So we need to map our data model around it. We need to optimize for queries, so those queries are fast. We don't want to spend time. We want to sacrifice space for time. Okay, and this is like an application workflow. This is the way we have it presented here. We have queries, how basically like the step the user takes in order to get to some point in the application. It's a little rather simple example, but if you have a bigger application, this will look a lot more bigger and more complex. So after we identify the queries, now we have to create our tables. We have to map the conceptual to logical. So everything we did there, now we have to put it in tables, and we need to identify the tables and all of the relationships between the table, right? This is the application workflow, the clustering column, and the primary key. Not the primary key. The primary key is consistent of the clustering columns and what's it called? Right, the primary key. We have the conceptual data model, the access patterns, and then we apply some mapping rules and patterns, and then we have the Chipoka diagram, which is going to be our logical data model. This is an example of one application. We see it's very similar to the application workflow, but instead of just this, we have the actual tables here. We have the queries coming along, and after which query, which table we're going to get. All right. So physical data model, like I said, this is the SQL types, partitioning key, right? We have here a few examples of primary key clustering columns. They can be ascending or descending. We have a static column, secondary index column, counter columns. We have lists, set maps. These are some few of the types here, but there's a lot more here you can do with it. For example, like this part here this is the partition key. The three clustering columns, this together creates the primary key, which, like I said, is a lot more different than the primary key in the PostgreSQL, where it's actually just for uniqueness. We don't worry about uniqueness. First, we worry about the partitioning. So Cassandra doesn't support joins. That means we need to split up our data so we can join two tables. So we have to think about the queries, and we have to model our data based on the queries. So like you see here, we have comments by video, comments by user, right? These two tables are for one query each. So we need to like identify which queries are in the beginning and then model our data based on that. The way we create the primary key is we write primary key, and then we have the clustering key, the clustering column, and the partitioning key right here. So we see the partitioning key is actually the one that we'll be doing our operations on. So comments by video, the primary key includes the video title and the user login, comments by user. This is a little bit, this is comparison one by one, the two SQL and SQL, right? If you already worked with SQL, it kind of looks similar. The only thing is the difference is like the primary key and the clustering column order in which, but other than that, it's just pretty much the same. It's really easy to pick up. You just have to know a little bit about the creation of the primary key in order for you to write the SQL. So you say we have here the SQL on the right side, we have the SQL, we have the table name and the table type, pretty similar here, right? We have the table name, and then we have the relationships, and then which row in the table it relates to. Partitioning and storage structure. So one very important part of working with Cassandra is knowing how the partitioning and how the data is stored based on partitions. So though that's really the important thing, you need to know where the partitioning key, and depending on how many partitioning keys there are, that's how many partitions are going to be created in the data model. And when we query the data, we query by partitioning key. So that's why our queries are going to be so fast, because we give it the partitioning key and it knows exactly where to look in the database. So it gives us information really fast. We're optimizing for query performance. This is kind of like what I was talking about. We select from videos where ID equals 2. So if we just say select all, that's going to be an expensive query because we have to look in all 3 nodes and get back that information. And that's depending on if that's like a 1,000 node cluster, it's going to take a long time rather than like an example here, like 3 nodes. But if we specify the partitioning key in the query, then we're going to get back a fast result because it knows exactly where it is on the cluster. So the clustering columns is the way we order the data, right? In order. So we have a primary key which consists of the clustering columns and the partitioning key. And in this case, let's say partitioning key is 2014, and we have the clustering columns based like in some unique way, like a sorting order. So it goes 2014. This is one partitioning with two items. This is one partition with one item. And the way these 2 items are scheduled one by one is depending on the clustering sorting orders, the clustering column. Again, see, we have 3 different clustering, 3 different partitions here. And these all have 1, but this one has 2. And we can also do queries based on the clustering order, but we need first to specify the partitioning key as well. So if you have a clustering order, you can do operations on the clustering orders too in the queries, but you first need to specify the partitioning key. And lastly, I think the normalization actually, like I said, we don't do joins, so we create our data based on the queries. So whenever we try to scale and add something, we actually just basically we think of a new query and then we create a table for it. Comments by video, comments by user, right? And yeah, that's about it. Obviously, if you guys want to talk about like how we include Spark and Kafka into Cassandra, you guys, if you have some questions or if you want to add something, please go ahead. Yeah.
Thanks, Stefan. Yeah, does anyone have any questions?
I believe CSV.
Internally, the way that Cassandra stores table is in SS tables, which is sorted string table. We do have other, well, they're part of Cassandra lunch rather than data engineers lunch, but we have other talks on that specifically.
Yeah, great presentation. Thank you. You had mentioned that Cassandra has pretty robust capabilities to sync between data centers. Could you talk about how to do that and manage multi data center operation without getting without incurring very expensive like bandwidth costs?
So the only thing I know is you can set up multiple data centers, right? And then you can set local quorum, so the way the data is replicated between the data sets. But in order to decrease bandwidth cost. I'm not sure exactly if somebody here has worked like practically with it and can have like a little bit more insight into it. Can follow up on that question.
Yeah, I can answer that real quick before I get to run. So data centers they can be logical data centers or physical data centers. But there's two types of traffics. There's internode traffic, and then there's inter-data center traffic. So I think Stefan was mentioning local quorum versus, let's say, global quorum. When you write data, it replicates, let's say, 3 times in a local data center, right? It only needs to be sent once to the other data center. And then that data center, if you have 3 replicas, the remote data center will then take that and it will automatically replicate it. There's also internode compression. And especially in the later, newest version of Cassandra, they have much better kind of usage of the Netty library as well as compression in general, where data is streamed much faster and it's replicated much faster. But at the end of the day, when you write data, if you want it to be replicated in full in the other place, at some point the mutations are going to go over there, right? It'll do its best job possible, but it's going to have to copy the data. It's not like we have wormholes where we just move, put data somewhere and it kind of shows up magically. But the benefit of kind of using data center replication is that it's not just that you're moving data from here to here. You can have writes in this other data center, and those will also trickle over to this other side. So it's bi-directional. And all of those, we call them mutations because it's basically a mutation to the immutable data set, and those get compacted. Those mutations to the data, they trickle over, and that's one like transactional trickling over. But every now and then there's something called a repair process, and repair is just a forced synchronization. And that forced synchronization doesn't do a copy. What it does is it actually uses a built-in technology under the hood of Merkle trees, and the Merkle trees are used in a lot of different places in computer science. But a Merkle tree is basically a tree of hashes from all the way to the top of the table, all the way to the bottom to maybe even the cell value. And it only even looks to see if it needs to synchronize something if there's a mismatch in the Merkle trees, right? So then if it sees a mismatch, it goes to the next level, And it only basically copies data if it needs to be copied. If it doesn't need to be copied, it still takes time to repair it, but it doesn't copy everything. Does that answer your question, Will?
Yeah, I think that does. Was just wondering if there are any thoughts on best practices, which you've answered very well. It's unfortunately hard to get around the bandwidth limitations or bandwidth costs when you want to get data between places. So thank you.
Yeah. Well, at least in so DataStax has a Cassandra as a service now, which they are using some cool concepts where they write data onto one data center and they read from the other. And they're eventually going to be, I think, open sourcing it. But the way it moves data is via S3, right? So that's your wormhole, basically. But that's not yet out there for the open public yet. But that's the closest thing to a wormhole that I've seen. I think Gotham has a question. What file format does Cassandra store data? No, it's not Parquet. Cassandra stores data in something called SS table, sorted string table. Sorted string tables are a common structure that are used in different databases. A big table uses sorted string table. RocksDB uses sorted strings table, but it's basically, if you unpack it, it looks like JSON, and it adds data as key value pairs, and every now and then it does a compaction. But that's a commonly used SS table format is not the exact same format as other databases, but it's a concept. And the second question was, is data update delete possible in Cassandra or only append? No, so everything, right? An update is an insert. a delete is an insert. Everything is a delete. Sorry, everything is an append in the sense that if you add data, it adds it to the SS table. If you delete data, it says this particular key is no longer there. That's called a tombstone. So that's an append as well. Any update, again, it doesn't go find the data and update it. It just says this data is now this. So when it does that, in memory, Cassandra is storing a mem table. When you put information into Cassandra, it stores something in memory so that when you retrieve it, you'll get it back. But every now and then it flushes it to disk, right? So when it flushes to disk, it goes into SS tables. And then every now and then it has to compact these things because you have a lot of inserts, updates, and deletes. You're not going to be able to quickly retrieve data because you have to then like read it all to reconcile it. So there's this kind of balancing act between when you write data and retrieve it versus when you write data and then you retrieve it much later. In the back, Cassandra is doing a bunch of different things. So it's flushing data to SS tables. It's compacting SS tables to make it more optimized. And the read and write path are I would say the easiest to explain. And this is kind of outside the scope of this answer. But the read and write path are fairly easy to understand. But it's not Parquet. It's something called SS table. Which, by the way, one last comment about it is that it is a format that you can read and write to. And there have been some talks in the past on Cassandra Lunch where you can read SS tables with Spark and write SS tables with Spark too, if you wanted to. And some companies do that. They take data from Cassandra as native SS tables and then they do something else with it. I don't know why, but well, I do know why. I'm not going to say it. Thanks. Hopefully that answers your question.
Okay.
Good show, Stefan. Thanks so much.
No problem. If anybody has any questions, feel free to unmute and have a discussion.
I have a question, and more so not in relation to the topic, but if anyone here has topics that they would like us to cover or would like seen, definitely share with us what you'd like to get out of some of these future webinars moving forward. We're definitely open to taking ideas to present on.
I'd love to see talks on data quality testing, specifically within the context of ETL or in data store transformation for figuring out how we as data engineers can provide or can be confident that our data is good.
Okay, yeah, definitely look into that as a topic.
So yeah, that's a really important topic. A lot of organizations are trying to do the ETL and referential integrity. Number of languages, as you mentioned, SQL and SAS. I think there's PostgreSQL. There's also obviously Cassandra here, and yeah, a number of tools and methods. Maybe you want to take a deep dive into a few of them.
Yeah. Thank you, guys.
Those would be cool. It'd be also interesting to look more maybe at frameworks in terms of, say you have a database or a data warehouse, Postgres, Cassandra, BigQuery. How can you go about adding tests like that?
Yeah, so some testing topics and kind of like QA almost.
I'd also be interested to see more topics around, I guess maybe more of data ops, but sort of like data lineage and providing insight into data flows and sort of all that metadata.
Okay, I know it should be up soon, posted soon, but Stefan actually also just did a talk on data bands, which kind of sounds like it would fit in for some of these use cases.
It was basically like a data observability platform where you can observe the data transformation, the data schema. Yeah, I think the video will be up, but it was a good presentation. The CEO was there. He explained it really, really good last week. If you guys want to check that out, it's on YouTube. It should be though pretty soon.
Awesome. Thank you.
Okay, it looks like Sudhakar, performance management in Cassandra as well.
It's good to write that down. We got a lot of topics for next week. Next
Yeah.
month.
Yeah, we appreciate it, you guys.
Yeah, and then also, if you guys want to present on any of these topics, so because this is a community, you're more than welcome to learn something and then present it, right? So the best way of showing that you're able to pick up something or a new skill or a new tool is presenting it and teaching it to others. So generally, Will has given 2 presentations surrounding Airflow. So that was something that he's worked with, but if it's something that you want to learn, so like some of these topics that people are suggesting, if it interests you, you're more than welcome to learn about it and then reach out to us and we can put you on the schedule to give a talk about it.
Yeah, definitely worth mentioning. Thanks, Arpin. That yeah, we love having guest speakers on here. A, it's always good to hear from our community, but B, it also helps with our own workload here. So yeah, to follow up with what Arpin had said, if anyone wants to present, definitely feel free to reach out to Arpin or myself. Drop my email in the chat right now. But yeah, just go ahead, reach out. We can set up a date. And we typically announce events about a month beforehand. Currently, we do have 1 guest speaker coming up in August, but we are always open to more guest speakers. So if anyone wants to present at any of these upcoming, it could be this, or if it's something more Cassandra specific, we could have you present at our Cassandra lunch as well, which occurs on Wednesdays. So definitely reach out to us, you guys. And if there are no other questions or topics or anything that anyone would like to discuss, we can go ahead and give you guys 10 minutes back, well, about 12 minutes back. If there's nothing further, you guys.
Thank you so much. This was great. Happy Monday, all.
Yeah, thanks, Will. Thank you, Stefan, for stepping in. Definitely big kudos. We told him about an hour ago that he'd be presenting, so it's huge to have him step in the way he has. So thank you, everyone.